Welcome, college algebra students. This is your test preview for Math 158. Note that all of these problems were coming out of Chapter 7, working with rational expressions and functions. I want to sort of step you through each section and show you sample problems and give you a few hints so that come Tuesday night you'll be okay. 7.1 was reducing and also multiplying and dividing. And remember, in this section I had mentioned that it's really just a factoring problem. As we look at some of the assigned homework problems, 25 was assigned. Make sure you do it. I'm going to do 26, which was not assigned, but very similar to 25. Here is 26 out of the textbook. It has y cubed times y minus 4, and that is divided by y squared times y minus 4. And the directions simply say, write the rational expression in lowest terms and then give the explanation that's asked. So basically, we're asked to reduce this. Well, this is a especially easy problem. Let's see, it's already factored, so we can just cancel. This cancels with that, and then that leaves us y, right, y cubed. And we have a couple of factors of y on the bottom, so we can cancel those, and we end up with just plain old y. Easy problem because it's already factored. Okay. Look at a problem like number 38. Okay, so for problem number 38, now 37 was assigned. Make sure you do 37. But in 38, we have this, m squared minus 25, and we have 4m minus 20. And again, the directions say reduce, and then try to explain what you did. Okay, so this is, again, problem number 38. It's not one of the homework assigned problems, but 37 was. Okay, so how do we do something like this? Well, remember, these are factoring exercises. So you need to factor the top. That looks like a difference of squares, m plus 5, m minus 5. And you need to factor the bottom. Take the common factor of 4 out, m minus 5. And then after you factored, you can cancel. So our final answer, m plus 5 divided by 4. Now, why was this not as easy as the previous problem? Here's the previous problem, remember. This one was already factored. Super easy to do. You just start wiping things away. The one we just did, not as easy because you needed to factor first. Okay, so there's a couple of examples that you can look at. Let's look at slightly more complicated problems. Now, as we go through the problems that we're looking at, these reduce, multiply, divide type things, and again, 7-1, I'm going to give you 5 problems out of 7-1. 5 problems out of 7-1. One of the problems will have a couple of trinomials, top and bottom, and you're going to have to factor first. Okay, so let's see, I don't particularly want to do your homework for you. Number 43 was assigned, but let's try a similar problem. Let's try problem number 42. 42. So if you look at it, you have a y squared minus 5y minus 14. That's the numerator. And on the bottom, you have y squared plus y minus 2. And again, the directions simply say reduce. Now, before you do anything, you have to factor. Must factor first. Must factor. Most of these problems are factoring exercises. Okay, so let's see. Up top, we need two numbers that multiply together to give us -4, but add up to a -5. So that sounds like y minus 7 and y plus 2. Okay. For the bottom, we need two numbers that multiply together to give us -2, but add up to a +1. So that looks like y plus 2, y minus 1. Now, if you're at all unsure, you really want to check these, because if the factoring's wrong, the rest of the problem is going to be wrong. Notice that if I FOIL this out, that's a y squared, there's a 2y, there's a minus 7y, and then there's a minus 14, and sure enough, these add up to what we need. So the top is okay, and then just checking the bottom to make sure that we didn't goof up here. We've got a y squared, and we have a minus y, and we have a plus 2y, and we have a minus 2. And sure enough, these go right to there. Okay, so we factored it correctly. Let me take all that stuff away so we can just go back to our simple problem. Once we factored it, then you simply cancel. So that goes out with that. And the final answer, y minus 7 over y minus 1, done. Can't do anything after that. Okay, suppose we had a more complicated problem. Let's see. Multiplying and dividing, but you have lots of stuff going on. I see a bunch of problems like 67, 68, 69, 70. Let me pick problem 69, just to show this exercise. So in 69, we've got 2x plus 3 times x minus 4 divided by x plus 8 times x minus 4, and that now is divided by x minus 4 times x plus 2, and that's divided by x minus 4 times x plus 8. And the directions say divide. Okay, well, this division sign says we know how to do that. We simply leave the first fraction alone, 2x plus 3, x minus 4, x plus 8, x minus 4, and then we're going to turn this into a multiplication problem, and remember, flip these upside down. So the bottom part will go on top, x minus 4 times x plus 8, and the bottom part right here, or the top part, will go on the bottom, which is x minus 4 times x plus 2. Once you have it as a multiplication problem, you can just turn this into one giant fraction, and then you can start canceling. Well, in point of fact, we could have canceled these right off the bat, but they cancel there, and these will cancel over here. We could have canceled those right off the bat. I mean, this was a really easy problem. Anything else cancels? Well, yeah, the x plus 8s go out, okay? And it looks like what we have remaining is the final answer. So up top, we have 2x plus 3, and on the bottom, we have x plus 2. A particularly easy problem because everything was already factored. Already factored. No factoring required. Wasn't that a simple problem? Yeehaw. Okay. Now, looking at the test next, let's suppose we have a division problem where one of the denominators is missing. Let's see, problem number 75 was assigned. To make sure you play with that, let's look at number 76 as sort of a sample. So we have 8y minus 16, that's in parentheses, and that's divided by 3y minus 6 over 10. And the directions say divide. Okay, so whenever you see this, you can assume this is over 1. So we have 8y minus 16 over 1 divided by 3y minus 6 over 10. Okay, this is a division problem, so remember we have to invert and multiply. 8y minus 16 over 1, leave that alone. But now turn this into a multiplication problem and flip these over. 10 on top and 3y minus 6 on the bottom. Okay, so we're setting this up now. The next step is to factor. Factor, factor, factor. Can't cancel unless things are factored. So up top, there's a common factor of 8, y minus 2. We still have a 1 on the bottom. And here we have a 10. And then we have a common factor of 3, y minus 2. Okay? Because this is a multiplication problem, you're allowed to put it all over one giant fraction bar. We have 8 times y minus 2 times 10. And the whole thing is over 1 times 3 times y minus 2. And so we cancel as we can. The y minus 2's go out. 3 does not go into 80. So our final answer for this problem would be 80 on top, 8 times 10. And on the bottom, 1 times 3 is 3. Finished. Okay? Not terribly bad. The factoring was particularly easy. Okay, so expect 5 problems out of section 7.1. 7.2. 7.2 is the adding and subtracting. I'm only going to give you one problem there. Take it back. Let me give you 2 problems. And let me give you an example that might be useful. Let's see. Look at a problem like 19. Now, even though we said addition and subtraction can be difficult, problem 19 is particularly easy. How come? We have minus 3p plus 7, and we have this denominator, p squared plus 7p plus 12. And to that, we're adding 8p plus 13 and divided by p squared plus 7p plus 12. Now notice the directions say add, and when we look at the 2 fractions, the denominators are exactly the same. They already have a common denominator. So you can simply write down the answer is going to have the p squared plus 7p plus 12, and up top we're just simply going to add these up. So there's a minus 3p there, there's an 8p there, so that's 5p, and then for the constants we have 7 and we have 13, so that adds up to 20. Now even though we've added it, we haven't completed the problem. The problems say add and then simplify. So we have to take our answer here and see if this can be simplified. And right off the bat, when I look at this top here, I see a common factor of 5. 5 times p plus 4. And so perhaps the bottom can be factored, right? Perhaps the bottom can be factored. Let's see, p squared plus 7p plus 12. Sure, I've got 2 numbers that multiply together to give me 12 and add up to give me 7. So that would be p plus 3 times p plus 4. If you're unsure, go ahead and double check by foiling this back out, but you would see that yes, this is the correct factoring. So now we can cancel, and the final answer is 5 divided by p plus 3. Okay? If you just left it like this, you're going to get a bunch of credit, but you're not going to get full credit because you didn't simplify. Okay, so there's an addition problem. Any other goodies that you're going to look at come Tuesday? Let's look at an addition problem where the denominators are not the same. Like I said, I'm only going to give you a couple out of this section. Number 55 was assigned. I don't want to do your homework. You do that. But let me show you number 56. 56, we have 2x over x plus 4, and to that we're adding 3x over x minus 7. Notice the denominators are different, so we cannot add until we get a common denominator. We're going to multiply this fraction by 1, and we're going to multiply this fraction by 1. And the objective here is to get a common denominator. So if I do x minus 7 over x minus 7, now look at that denominator. And if over here I go x plus 4 divided by x plus 4, look at that denominator, and now the denominators are the same. So let me sort of rewrite this. Over here I have 2x times x minus 7 over this denominator, x plus 4 times x minus 7. And to that I have 3x times x plus 4 over x plus 4 times x minus 7. Now, you should know it doesn't matter the order that you put these two factors. So here I put the x plus 4 first. Okay, the denominators are the same. So that means I can add these up. So the common denominator is x plus 4 times x minus 7. And up top, I can go ahead and multiply these. 2x squared minus 14x. And then I'm adding. So let me multiply these. So that would be plus 3x squared plus 12x. Okay. Lastly, combine like terms. So 2x squares and 3x squares, that's 5x squares. And then combine the terms here. Minus 14x plus 12x is minus 2x. And on the bottom, I have x plus 4 times x minus 7. So I've done the addition. Now, you might want to double check and see whether it simplifies. There is a factoring that occurs up top. But notice there is a common factor of x right here. But that really doesn't do much for us. If I take the x out, I have 5x minus 2. On the bottom, I still have x plus 4 times x minus 7. So nothing cancels. This is our final answer. And you can leave it this way, or if you wanted to leave it this way, that would be okay too. Either one of those are correct. The key on this problem was finding the common denominator, and we did that at this stage right here. Okay, so a couple of addition problems on Tuesday night. Okay, complex fractions. That was section 7.3. I'm only going to give you one problem. Let me give you a typical example. Let's see, you had to do number 17, but let me do number 18. Number 18, very similar. We have 4t squared minus 9s squared all over st, and then that fraction is divided by sort of a thick fraction bar here. It's divided by 2 over s minus 3 over t. And the question is reduce, simplify, divide, whatever you can do. Probably the best way to do this, the nice technique the author shows you, is if you multiply top and bottom by the same expression. Now remember, you can always multiply by 1. So what form of 1 do I choose? I'm going to choose st divided by st. Now I hope you would agree that st divided by st is 1. So I'm multiplying this whole thing by 1. Why do I do it? Well, watch what happens. For the top, when you multiply this st, this guy right here, it cancels with this one. And we simply get 4t squared minus 9s squared. On the bottom, when we multiply this, we're going to have to distribute here. We have two terms. So in the first multiplication, the s cancels, and we get 2t. In the second multiplication, the t cancels, so we still have a negative 3s. Okay, so that cleans up the fraction immensely. Are you finished? Well, not quite. You do have the thing cleaned up, but remember we're supposed to reduce as much as possible. So now try factoring. If you look at the numerator, that's a difference of squares. 2t plus 3s, 2t minus 3s for up top, and on the bottom you have 2t minus 3s on the bottom. So yeah, go ahead and cancel those, and then you're done. Final answer is 2t plus 3s. Okay, so one complex fraction, 7.3. Let me go ahead and stop this video here, and I'll shoot this as one YouTube link, and then I'll talk about section 7.4 and 7.5 in a separate video, and you'll probably get that first thing in the morning maybe. Okay, happy studying.